Hello, this is Nas from NB Network Lessons. Hope you guys are doing okay. I'm back as promised with an example which shows how do we solve for KCL or Kirchhoff's current law. So this is circuit analysis lesson number 7 and we're going to have Kirchhoff's current law KCL. This is basically a diagram which I drew for you already. Okay. So in this case, as you can see, we have a voltage source and then we have R1, R2, and then the current splits over here. Whatever current I1 is coming over here also, it splits. Some of it goes to R4 and some of it goes in this direction towards R3. So the question is, what is the current at this node A, the one in red? So let's look at that. So if I write the equation, I know I1 is going towards the node. As I explained you, if it's going towards the node, it's going to be minus I1. Now, our I2 is leaving the node, so that's going to be plus I2. And this current is also leaving the node, I3. So according to Kirchhoff's law, sum of these currents is 0. So how's that? All right. Now, what we are asked is to find I2. Okay. We don't know what the I2 current is. We know what I1 is. We know what I3 is. So can we find I2? Of course, we can use this equation and find I2. What we can do is we can isolate I2 using our algebra, and then we can say I1 minus I3. All I'm doing is that I left the I2 on the left hand side of equal to, and then I moved negative I1 on the right hand side of the equal to, which when I do it becomes plus, and then I move the plus I3 on the right hand side of the equal to sign and becomes negative. So then I2 would be equal to, what is my I1? I1 is 10 amp. Okay. And then what is my I3? I3 is 2 amp. So here we go. We know what I2 is now. I2 is 8 amp. So I can put that down right here. By the way, this voltage source is 100 volts. Okay. Now, the next question is, what is the voltage at R3, voltage drop at R3? We want to find out the voltage drop across this resistor right here, the 10 ohm resistor. So how do we do that? Well, we can use the Ohm's law, okay? So voltage drop at R3 would be equal to, V is equal to IR, I2 times R3. So I2 is going through R3. So if I want to find voltage, I apply Ohm's law, and then this becomes I2, I know I calculated it 8 amp, times R3, I know it's 10 ohm. So then the voltage drop at this resistor is going to be 8 times 10 is 80 volts. Okay, how's that? Now let's look at what would be the, let's see, voltage drop at R4. Okay, so that's a little bit of a tricky question, but but let's look at it. So voltage drop at V4, I'm talking about right here on this. So that would be equal to current, which is I3 times this resistor, which is 40 ohms. So the answer is, let me just do this. This is R4. So the answer would be 2 times 40 is equal to 80 volt. And it makes sense because this resistor right here, the terminal of this resistor connects to this resistor right here. Okay, so both of them have a common point for the node. So whatever the voltage drop is going to be here, it's going to be the same voltage drop right here, and we just proved it. Okay, so now the next question is, what would be the voltage drop at resistor 4? We just solved it. What would be the voltage drop across R2, this resistance right here? Okay, let's calculate that. So V sub 2 at resistor 2, my current I know is 10 amp. Okay, and then I know the value of resistance is 2, 10 times 2, so that gives me 20 volt, which makes sense. If you look in here, the voltage source is 100, right? And then I've got this part right here, I've got 20 volt, and then this part right here, I got 100 volt. So voltage over here, voltage drop over here is 80. So 80 plus 20 is 100. So that proves that, you know, the voltage source, which is 100 volt, matches the voltage drop across two resistors. So this was an example I wanted to share with you. And also, just to let you know that there is something to remember, that in Kirchhoff's law, you can have n minus 1 nodes. Okay, so remember that in Kirchhoff's law, you can have number of nodes is equal to n minus 1. Okay, all right. Whereas n is the number of basically, let's say you have 2 nodes or 3 nodes. Let's say you have 3 nodes, then you can have only 2 KCL equations. If you have 2 nodes, okay, then you can have only 1 KCL equation. That's what this thing is trying to say. N is the number of nodes. Right here, n is the number of nodes. So let's say if you have, in a diagram, you have 6 nodes, right? So then how many equations you can have for KCL? N minus 1, 5. So in this particular case, if you look in here, how many nodes do I have? If you're looking here, if you look right here, I have, this is a node, right? And this is a node, okay? So then, how many equations, KCL equations I can have for this, okay? I can have 1. Why? Because I have 2 nodes. Nodes are where the other resistors are interconnected. So this node has R2, R4, R3 connected, right? And then this node has R3 and R4 connected. So then it's basically the number of nodes. In this particular case, I have 2 nodes, so I can only have 1 KCL equation. So that's all I wanted to say. Thank you so much for watching. If you like the video, please go ahead and share as much as you can. I would really appreciate that. Sharing knowledge is great, and also sharing is caring. Thank you, and go ahead and give me a like if you like the video. Thank you so much.